is the soldier system, the right weapon at the right time. The Vought Corporation of Dallas, Texas, and its hand-picked team of experienced contractors have developed the GSRS soldier system for the U.S. Army and our NATO allies. Thanks to our early start on the program, Vought enjoyed a wide-open choice of supporting vendors to form the Vought GSRS team. This outstanding team is producing the best system possible. The heart, brains, and muscle of the soldier system is the self-propelled launcher loader, the SPLL. Built around a derivative of the proven XM2 infantry fighting vehicle, the SPLL has exceptional cross-country capabilities. It can travel at sustained road speeds of 64 kilometers per hour. The soldier system matches the high mobility of today's Army. The first carrier vehicle was delivered from the FMC Corporation in San Jose, California, to the Vought plant in Dallas on 11 November 1978. Within several weeks, the three major structural assemblies completing the SPLL were fitted and installed. The actuators, electronic components, computers, hydraulics, and mechanical components were fitted and checked out as a system for the first time. FMC's #1 carrier vehicle became Vaught's #1 SPLL, the first of 3 built by the Vought team during the validation phase. SPLL #1 emerged from our prototype shop, ready for form, fit, and functional checkout operations. On 12 March 1979, it was shipped to White Sands Missile Range near Las Cruces, New Mexico. It has set numerous competitive records, including the first rocket launch from an SPLL, the first triple ripple, the first 6-shot ripple, and the first single-shot and triple ripple launches with men inside the SPLL cab. By the completion of the validation program, more than 100 rockets will have been fired from Vaught's SPLLs. In the following ripple, the first 2 rockets were launched at a target 20 kilometers away, and the third was fired at a target 16 kilometers downrange. All 3 shots were on target. After in-house testing, Vaught's #2 SPLL was shipped to Redstone Arsenal in Alabama to support the government's engineering development testing program, then to White Sands Missile Range to support the instructor training and large group trials programs. Later, it will support SPLL #1 on the firing line. Vaught's #3 SPLL successfully completed the mobility and endurance test program at Aberdeen Proving Grounds in Maryland. These tests included operations on the 6-inch washboard course. There were cross-country and high-speed operations on gravel roads, and a 60% slope climb, 40% side slope operation, and a 36-inch vertical wall climb. The SPLL also took a series of passes through the tough Munson obstacle course at various speeds. This same SPLL was taken to Eglin Air Force Base in Florida for Arctic and desert testing. This included extensive exposure to temperatures from -25 degrees to +125 degrees Fahrenheit and other environmental extremes. Once again, the soldier system proved it can take it as well as dish it out. Loading and unloading from an Air Force C-141 cargo aircraft was verified before SPLL number 3 was airlifted to Fort Sill, Oklahoma for operational testing in the field by regular Army troops. The GSRS rockets launched by Vought at White Sands were assembled at our plant near Camden, Arkansas. Each Vought GSRS warhead contains 644 dual-purpose anti-materiel, anti-personnel munitions. Once sealed in the launch pod container, the GSRS round needs no further attention from factory to firing site. After contract go-ahead, this plant will be expanded, modernized, and automated to meet the Army's production requirements. We have covered 3 of the 4 major ingredients needed for GSRS operation: the SPLL to transport, aim, and launch rockets, the disposable LPC to store the rocket as well as shoot it, and the rocket itself. The final ingredient is the most important of all, the 3-man crew: the driver, the gunner, and the section chief. Vaught's GSRS soldier system is designed for the soldier, both in training and in combat. In a typical operation, a fully loaded SPLL moves into a firing site. Under combat conditions, the soldier system can load and shoot a dozen rockets, scoot from the firing site, reload with 12 more rockets, and fire that load faster and with more punch than any comparable artillery system. The soldier system is self-laying and self-aiming. It also re-aims automatically between rocket rounds, even in the ripple fire mode. Up to 3 separate targets may be programmed into the fire control system at one time. Safe inside the armored CBR-protected cab, the gunner can command the soldier system to automatically engage each target in succession. After the fire mission, the soldier system scoots from the launch site before enemy counter-battery fire can be launched and travels to a nearby ammunition storage area. Undetected, the crew can rapidly reload in comparative safety. As the crew dismounts, the fire control system automatically positions the launcher-loader module to unload the empty launch pod containers at the rear or over either side. The section chief uses a portable boom control device to lower the LPCs simultaneously. The driver and gunner unhook the empty LPCs. The section chief then rotates the launcher-loader module to the rear of the SPLL to pick up the 2 loaded LPCs simultaneously. This ability to handle 2 LPCs at the same time considerably reduces the mission reaction time of the soldier system. After attaching the hoisting hooks, the driver and gunner remove the quick disconnect pins holding the shock attenuating skids. The skids drop away as the hoist lifts the LPCs. The crew checks for proper seating of the LPCs within the launcher-loader module. Then they electronically check out and attach the umbilicals connecting each rocket to the fire control system. The LPCs are locked into correct alignment while the section chief stows the portable boom control device. The launcher loader module automatically rotates to the travel position while the crew enters the cab and prepares for another fire mission. One distinct advantage of the soldier system over comparable systems is its ability to be unloaded, loaded, and fired by a reduced crew, even by a single crewman. In the single crewman mode, the soldier system's characteristic quick turnaround time is extended slightly, but the end result is the same. For example, the automatic segment of the unloading operation is essentially the same, up to the point where the single crewman must put down the boom control device to unhook the empty LPCs. The longer boom controller cable planned for the production SPLL will eliminate this inconvenience. Rotating the launcher loader module to the rear of the SPLL is the same operation with one crewman or with three. However, a single crewman operates the boom controller as well as attaches the hoisting hooks to the loaded LPCs. Both LPCs are loaded simultaneously to save valuable turnaround time. The single crewman then stows the portable boom controller, performs the electronic checkout of the two LPC umbilicals, and locks both LPCs. The fire control system automatically stows the launcher loader module for travel, and the soldier system is ready for the next fire mission. Whether operated by the standard three-man crew or by a reduced crew, the net result is the same: more steel on the target at less cost than the Army's goals. The Soldier System, a product of the Vought team.